In this next video, we'll be trying to solve cosine of 2x plus sine of x equals to 0. Now there is a slight issue with this particular equation. You'll notice that once again we have a double angle and a single angle in the same equation. Now when working through identities, the expectation was to never have a double angle and a single angle together in the same problem. So it might make sense in an equation for us to make the same argument. So our goal then is to either change the cosine of 2x to be a function in terms of a single x, or to solve or to manipulate sine of x in terms of making it a double angle. What I'm going to do then first is, by looking at my identity sheet here, we'll notice that we have some rules of identities for sine of 2x, for cosine of 2x, for tangent of 2x. Noticing that cosine of 2x has, again, 1, 2, or 3 different possibilities. Again, this cosine squared minus sine x could be equal to what we're looking at. 1 minus 2 sine squared x could be what we're looking at. And 2 cosine squared minus 1, cosine squared x minus 1 could be what we're looking at. Well, what I'm going to do is, based on the fact that I've got cosine of 2x plus sine of x, and the fact that this identity allows us to transition it to either cosines and sines, or just cosines, I'm going to go ahead and transition it to just sines. And the reason for that is because then I can treat it as though it's behaving like a quadratic form. So cosine of 2x, based on this identity, is equivalent to, and again I'm skipping over this first case, I'm looking at the second case, 1 minus 2 sine squared x. So I'm replacing cosine of 2x with 1 minus 2 sine squared x, plus the sine of x equals to 0. Now that I've transitioned this so that they're all singular numerical values of the angle on the inside, I'm now going to go ahead and rearrange this so that it appears as though, again, negative 2 sine squared x plus sine of x plus 1 equals to 0. This is nothing more than, again, a previous example of solving a quadratic formed trigonometric equation. I'm going to first multiply everything by a negative 1, giving me 2 sine squared x plus, minus sine x minus 1 equals to 0. And then I'm going to go ahead and use, again, that factoring method of what two numbers will multiply to get me a negative 2. That will add to get me a negative 1, and the values are a negative 2 and a positive 1. I'm going to go ahead and tear this function apart, again leaving the first term as it is, sine squared x, tearing this apart into minus 2 sine x, and then change this to plus 1 sine of x, and then minus 1. I'll draw my line down the center here, factoring out of these two terms a 2 sine of x, leaving me with sine of x minus 1. And out of these two terms, I'll factor out a positive 1. I know technically I'm not factoring anything out of these two, but I have to have something to share between this term and this term. So, in that case, I end up with 2 sine of x plus 1 as one factor, and the sine of x minus 1 as the other factor, equaling to 0. Again, because that's what it was equal to up here. Make note that we do not have to use this factoring method in the version of sines and trig functions. We can return to using that this is 2x squared minus x minus 1 equals to 0, if that so helps. So once we're here, we will set each of these two different functions equal to 0, and solve them just like we did the previous cases. In this case, sine of x equals to negative 1 over 2, and sine of x is equal to 1. In both of these situations, again, they do appear on the unit circle, in which case we do not need a calculator to solve these problems. On the unit circle, we're once again looking for the sine of x equals to a negative 1/2. That's this location down here at 11 pi over 6 and 7 pi over 6. And we're looking for the sine of x equaling to a positive 1, which is once again at pi over 2. So that's giving me x equals to pi over 2 as one solution, and x equals to 1, once again, 7 pi over 6 and 11 pi over 6 as my other two solutions. Both of these solutions, all three of these solutions should check. And it is necessary that you do go through and plug them back in to ensure that they actually work.